Hello, everyone, and welcome to CSA's webinar series, CSA Cloud Bytes. Today's webinar is titled How to See AWS Workload Level Risks Without Agents, Modern AWS Security Best Practices. Just a few housekeeping items before we do get started. You can enter questions that you have at any time during the presentation. Just use that Ask a Question tab that's at the bottom of your screen. We'll reserve time towards the end of the webcast to address these questions. Additionally, the slides from this webinar are going to be sent after the webinar has concluded by Orca Security, so be on the lookout for that email if you're interested in the slides. All right. Today, I'm really excited to be joined by a lovely panel of experts. First up, I have Sunil, who is the CISO in residence at Weil Ventures, formerly the Chief Security Scientist at Bank of America. Sunil, can you introduce yourself and tell us a little bit about what you're going to share with us today?
Sure. Thanks, Hillary. So as Hillary mentioned, I used to be the Chief Security Scientist at Bank of America, doing a number of things around research and development of new capabilities for security. I'm currently the CISO in residence at Weil Ventures, which is a American-Israeli venture capital firm that focuses on early-stage Israeli cybersecurity startups. So today I'm going to talk about the cyber defense matrix and how to use that to understand all the aspects of cloud security and ensure that you have complete coverage of the things that you need to protect.
Awesome. Our next speaker is going to be Arent, who is the Senior Cloud Security Engineer at Census. Can you introduce yourself a little bit and tell us about what we're going to be hearing from you about today?
Yeah, thank you, Hillary. So my name is Arent Brown. I'm the Senior Cloud Security Engineer at Census. I come from the background of a full-stack engineer where I was deep in the building of product code. So during this time, I was also acting as a security champ, so I was taking part in hackathons, incorporating security trainings into my everyday coding practices, and also, otherwise acting as a security lead for my teams at the time. So since I've moved into security, I've helped build out our security capabilities in the cloud. And so I'll be speaking to that today, some notes from the field and some general best practices and how to help scale your security organization along with your engineering assets.
Wonderful. And our last expert for today is Avi, who is the co-founder and CEO at Orca Security. Avi, can you introduce yourself and tell us what we're going to hear from you?
Thanks, Hillary. Yes, I'm Avi. I'm the CEO and co-founder of Orca Security. In fact, I've been involved in cybersecurity since I was 13 years old as a teenager. I've been a decade in the Israeli intelligence and more than a decade in Checkpoint. In the last few years as the chief technologist. And in late 2018, I and additional 7 co-founders founded Orca Security, providing full-stack visibility for cloud environments seamlessly. So let's move forward and I'll explain a bit about that and what we've been up to and why we created it. So in Orca, we've created a unique capability. It's based on a technology called side scanning that provides 100% full workload level visibility for your cloud environment, and I mean about AWS, Azure, and GCP, without agents, literally without sending a single packet, without running a single opcode. We're able to provide complete coverage to the workload, application, and data layers, and using the metadata that the cloud provides, even reduced the large number of issues that we detect to the few ones that are actually matters and can be exploited by external attackers. So I know that this many times sounds like snake oil or something that it's not possible. We've been used to do security in dramatically more tedious ways. And what we are going to show is why it's possible. And the reason that it's possible is because of the cloud, of the progresses that came with the cloud, with the underlying technologies that allow us to do security in a dramatically better way than we used to do in the pre-cloud world. So let's have a quick look on the way that we used to do security before the age of the cloud. We used to have data centers, and when we wanted to secure data centers with physical machines, you don't really have tons of options. You can deploy agents on your machines. The agent resides on the host and naturally see everything that runs on it. They can detect issues in the operation system, application, and data. Or you can communicate from the network, deploy network scanners that will try to probe them from outside in and detect any issues. Now, if you think about that, on the on-prem environment, there is absolutely no alternative. You are, at the end of the day, probing a machine, a physical machine, sitting in a dark and cold data center, and the only way you can reach it is by running a piece of code on the workload as an agent or communicating from the network. This is literally the physics of the problem, the rules of the game. Either install something or come from the network or you won't see it. So all of the players in this market for decades implemented these mechanisms that of course have their advantages, but also the drawbacks, the fact that you need to install agent, to integrate network, scanner, etc. But this was everything that you could have done. When the cloud came, we essentially took the exact same technologies, the agents, the scanners, and moved them to the cloud. We did it because at the end of the day, it was easy for us to think of the cloud as an extension of the on-prem world. If we had machines, we had virtual machines, we can deploy agents. We had networks, now we have virtual networks, we can use the scanners. And another kind of beast came, the CSPMs, the Cloud Security Posture Managers, the tools that reside in the cloud. They examine the metadata and can detect deviation and misconfigurations from the best practices. They don't go into the workload, but they can detect any issue in the cloud control plane, whether the IAM role is incorrect, the VPC configuration is wrong, or using accounts with no multi-factor authentication. And this is essentially the situation as most organizations do today. We took what we used to have and augmented it, including the drawbacks, the fact that you need to install agents and you are not going to cover your entire environment using that. There's absolutely no chance to configure network scanners if you use that. But we never paused as an industry to think, what is the right way to do it in the cloud? And this is exactly what we did. And we understood that there is a better approach, and we call it side scanning, that leverages the capabilities of the cloud provider itself to scan without this need for tedious integration on a per workload basis. So we don't, in side scanning, there's no agent, no network scanners, no CSPM. Instead, the secret sauce is that Orca collects data directly from the workload's runtime block storage and augment it with data from the cloud metadata. And by doing that, it's able to gain the immediate understanding of the deficiencies of the environment and their relative importance. I'm going to share soon some of the common things that we many times see, but the main takeaway here is that due to the improvements in the cloud providers themselves, you no longer need to install anything on each workload. You no longer need to integrate on each and every one of them, but you can leverage the cloud environment itself to distribute the security, to provision security inside of the environment. So the values of this is things that were unheard of on the on-prem world. The comprehensiveness, no need to pair workload integration, complete coverage, current and future, because you're integrating at the infrastructure layer. It literally minutes to set up because you don't need to change anything. And last but not least, zero impact by design. It doesn't run on the workloads, it doesn't affect them, it can't change anything on them. If you think about it, the reason it's possible is because physically in cloud providers, the workloads have a separation between the compute and the storage. The runtime block storage sits on a different box that is connected to the compute nodes. Due to that, what Orca does is getting read-only access to the account runtime block storage and utilizes this access to secure the workloads without affecting them, simply by reading the shared storage layer and combining the data with the metadata read from the cloud environment. So let's move on, and I'll run a bit and share about the common things that we see. This technology is used within customers from many different industries, starting from fintech, cloud-first companies like Sisense and Data, People AI, and Cubo, that when we have Aaron here from Sisense that will share about how he sees it within his environment to very large enterprise customers. One of the things that when we use our technology, we see some risks that are essentially frequent in almost any environment, and I'd like to share some of them with you. And I think that many of them don't get the same the priority and severity that they should have. So one of the first ones is what I consider vulnerable public-facing workloads. Everyone knows that you have many vulnerabilities in this environment. No need for me to tell you that. But the hard thing about managing vulnerabilities is to making sure that you know about the important one and all of them. At the end of the day, it doesn't matter if you have 10,000 or 100,000 vulnerabilities in your environment. You want to know about the ones that are internet-facing, that are accessible externally, and can be actually exploitable. One thing that we found is that many times there are many workloads that are not that are not handled and maintained correctly, and have internet-facing services with exploitable vulnerabilities. This is one of the top issues that we believe any security practitioner needs to handle. At the end of the day, the workload which is internet-facing either directly or indirectly through a load balancer, reverse proxy, etc., are the ones that are the easiest for the attackers to use in order to breach the organization. The second most common security issue that we see is what we call neglected workload. The fact that people work fast in the cloud creates many times a case where there's people in the organization that create workloads without necessarily deploying the organization practices over there, without involving the security teams. Many times these solutions are still, these workloads are in use, but they are not maintained from security perspective, sometimes for years. The easiest way to see it is simply that they haven't been patched for years, usually since they're installed, or running an out-of-date operation system. This is naturally a red flag, because if it's not patched for that long, there's likely many ways an attacker can use that to breach the organization. And any security practitioners need to make sure that he have a way to know about everything within his environment, whether it's an unpatched operation system, an operation system that cannot be patched. If you see that within your environment, it's very likely that nobody is actually maintaining this workload. The third one is lateral movement risk. At the end of the day, attackers will always try to get hold in your organization to get a way to reach a certain workload, but after they get that, the next thing that they will do is to try to find a way to move to other workloads or to the crown jewels. The easiest way for an attacker to do so is to find secrets or other or credentials stored within the workloads that they've reached that allow lateral movement. This can be in a way of a private key, SSH key that is stored simply for the sake of simplicity, an AWS key, or even a password in a text file. Each one of these, when found by an attacker, can be used to laterally move, and we as security practitioners need to make sure that we have the ways to find them before they do. Last, another one which is many times not in focus is the simply malware scanning. I saw so many organizations that have deployed many advanced solutions, but haven't made sure that they have a way to scan all of the environment for malware regularly. It's not enough to only scan it on them. When you deploy a piece of software, you need to make sure that it's regularly scanned, because things happen. You don't expect to find malware, but if there is malware within one of your workloads, something that's naturally very alarming, and knowing about that is the first thing, is critical in order to understand how you reach that point and how you can prevent it from happening again. Weak authentication. Many times there is a lot of focus on authentication on the cloud provider side. For example, making sure that there is multi-factor authentication on the cloud provider side of things. But there is authentication to the workload themselves. And you need to make sure that you verify both the authentication to the cloud provider control plane, the AWS root accounts, but also that there is no workload which is configured using weak credentials or weak authentication mechanism, because at the end of the day, an attacker can reach via both ways. And last but certainly not least, I don't think there is any presentation about AWS security that cannot put one of the most common issues, making sure that the ACLs for your data are correct, that you haven't by mistake opened your S3 buckets, including all of your crown jewels to your vault. It's so easy to make these mistakes, and because it's been done so many times in the past, it's critical to make sure that you have the mechanisms to verify that if something is open to the world, that there will be the right approval process for that. This is a great time to pass the presenter presentation to Sunil that will discuss the cyber defense matrix and how it relates to AWS.
Great. Thanks, Avi. Well, many of you may have seen the comic that says, there is no cloud, it's just someone else's computer. Well, that's true. I think it obscures the nature of the real shift brought on through the availability of public cloud infrastructure. And what I intend on showing you is to give you that view of the change as viewed through the cyber defense matrix. Now, infrastructure as a service has brought forth a fundamentally different model for how we build, operate, and secure IT infrastructures and applications. There are three key aspects that make the cloud radically different. First is that everything can be defined programmatically, so it's highly configurable and configurable by the developers who are actually deploying the applications. Second, we have a wide variety of discrete services that can be mixed and matched. And then third, the consolidated environments can simplify management and give us economies of scale. We now have this unified API for everything. Before we had to deal with multiple APIs from multiple vendors. Now we have a single API that we can use to build this environment. However, these qualities also have security implications. I mean, it's great that everything is programmatically configurable, but it also creates room for more configuration errors. And because everything is highly configurable, we're going to be prone to configuration errors. And the developers who configure these things don't always have guardrails or guidance on how to configure them securely. An infrastructure as a service provider like AWS offers us over like 175 different services. But this can create cloud sprawl with so many more individual resources that need to be tracked. And these include microservices, containers, serverless Lambda functions. And this is on top of all the traditional servers and networks and databases that we have. Lastly, with everything being in the same logical locations and accessible via an API that's exposed to the internet, we can't strictly rely on network-centric boundaries anymore. We now need some sort of identity-driven boundary versus strictly a network-centric boundary. So whether it's ensuring that you have the correct configuration throughout your environment, or losing track of what resources you actually have or are using, or managing secrets and identity and access management, many of these challenges are all too familiar. Even when you operate in whether you operate on-premise or on in a public cloud, these are all very familiar challenges. However, when dealing with cloud infrastructures, we are operating with orders of magnitude more than on-premise. But fortunately, infrastructure as a service providers gives us a new way to tackle these security needs. And this is what we're going to cover in this particular section. So in the previous slide, we talked about these three implications, and the Gartner Research Group regularly reminds us that nearly all successful attacks on cloud services are going to be the result of customer misconfiguration, mismanagement, or mistakes. Now, let's make this even harder by having now thousands or tens of thousands or even hundreds of thousands of individual resources that need to be tracked and properly configured. And as I mentioned previously, you have folks like AWS that offers, again, hundreds of different services, each with their distinct setup. How can we be certain that those who set up those services did it properly? And then lastly, take all that and put it into an environment where everything is commingled, and you can see how an incorrect misconfiguration needs to be found and addressed pretty quickly. The issue here is really one of scale. The flexibility and scale that we have in infrastructure as a service also means that we can make mistakes at scale too. And so we need tools and processes to prevent misconfigurations and vulnerabilities from the beginning, as things are being built. We want to be able to provide extensive visibility into our running cloud environment. We want to analyze that visibility to find misconfigurations and vulnerabilities in production. And most importantly, we want to be able to fix and patch them before they're exploited. So we need a new approach that adapts to the new operating model, which includes a fundamental difference in the security team, and that the security team is no longer doing the work to secure things, but rather it's the DevOps team that's primarily responsible for it. Right? We've essentially given the power to the people to set all this up without giving them the understanding of how to do it securely. So how do we get a grip on cloud security? Well, using AWS as an example, here there are some native capabilities in AWS that provide the foundational tools to secure our workloads in the cloud. If you have a team that understands how to thoroughly leverage these native capabilities, then you can build it yourself. However, if you're resource constrained on time or people, like many of us are, then we can leverage marketplace vendors that provide turnkey capabilities that tackle these security needs. There are two primary classes of cloud security tools that provide protective capabilities for cloud service providers. As defined by Gartner, the Gartner Research Group, they include capabilities such as Cloud Security Posture Management and Cloud Workload Protection Platforms, or CSPM and CWPP. So you'll see those acronyms later on as well. So a lot of the marketplace tools basically leverage the infrastructure as a service native tools and ensure that everything is properly set up and is compliant with best practices. To understand the differences between CSPM and CWPP, it's also helpful to look at frameworks and to understand how they relate to each other. And this is where the Cyber Defense Matrix comes in. The Cyber Defense Matrix is one such framework that can help us understand the differences and ensure that we're addressing the complete set of security needs in the cloud. So I originally created the Cyber Defense Matrix, which is what you're seeing right now, to organize cybersecurity vendors, and it's been extremely useful, and it's served in many different ways to address a number of different use cases. At the basic level, the Cyber Defense Matrix is an adaptation of the NIST cybersecurity framework, but with an added dimension that captures various classes of assets that we care about. These assets are devices, applications, networks, data, and users. This added dimension will help us improve our ability to find and fill gaps in our understanding of completeness when it comes to cloud security. And that was really the challenge. If I go back a slide and I show you all these different capabilities here, well, how do you know if you're missing anything, right? How do you know what these different capabilities are addressing? What problem are they solving? And so the idea is to be able to map them into the matrix. And by mapping them into the matrix, we can then see where there might be gaps. We can rationalize all the capabilities that we see and organize them into the matrix and ensure that we're covering all our bases. Now, as I mentioned earlier, there are two major classes of cloud security capabilities as defined by Gartner. They are Cloud Workload Protection Platform and Cloud Security Posture Management. Gartner shows them as being adjacent capabilities, one focused on the control plane, or the underlying infrastructure, and the other one on the data plane, or the workload itself. Bridging between them are a set of security services, and customers can leverage infrastructure as a service native capabilities or leverage marketplace vendors with similar capabilities. Now, if I flip this diagram around, it actually maps nicely to the Cyber Defense Matrix. Each asset class in the Cyber Defense Matrix represents a potential attack surface that needs to be addressed in cloud environments. While there may be some overlapping features, CSPM and CWPP generally address different parts of this attack surface, as shown here. Specifically, CSPM typically secures the configuration of the underlying infrastructure, such as S3 buckets, which is the data category, IAM roles in the user category, network security groups, and so on. CWPP typically secures the operating system, which is under devices, and then both CSPM and CWPP provide coverage of different parts of the application space. CSPM covers platform as a service, like Lambda functions, while CWPP covers containers. And both of these, the Lambda functions and containers are both aligned to the application domain. To show how this plays out with a particular cloud security vendor, here's an example with Orca. So I dug deep into Orca's demos and their product literature and mapped it in the following way. And as you can see in the diagram, it covers elements that are both in the CWPP as well as the CSPM side. And that's one of the main claims that Orca has in their product literature. Now, note that Orca is largely on the identify function. Since they're essentially doing a vulnerability assessment across these various asset classes in the cyber defense matrix. But note that they don't do protect, at least not that I could tell. What they do is they alert you to issues and provide you recommendations. But for the time being, you will need something else to actually go perform the protect function. But we also want to be able to see the more granular sub-functions that occur in each of these asset classes. And so let's actually double-click and dive into this further. So this is a table that's transposed from the previous view of the cyber defense matrix. We have the asset classes on the top and the sub-functions on the left. And within the function of identify, we have sub-functions like inventory classification and vulnerability assessment. Likewise, under protect, there's several activities that we perform, for which I'm only showing a very small subset. And this is really this is a non-exhaustive mapping of some of the native services in AWS. So there's clearly some I have left out. But if we look at this table and provide a more descriptive view of the activities that occur within each asset class, we can see that there are many sub-functions like vulnerability assessment or logging that can be applied to each of these asset classes, but they may go under different names. So, for example, if we're looking for vulnerabilities in a device, that would be basically like an operating system scan. Whereas if you're looking for a vulnerability in storage, that could be like looking for open buckets or exposed keys. In some cases, like classification, I actually lack the words to properly describe what classification looks like for, let's say, like networks or applications. But we can see that there are capabilities like data classification. We can see capabilities like data classification and see how that could be applied for not just typical sensitive information, but also for malicious information like malware and viruses. So if we then take this and map it to a product like Orca, at this level, we can again see more specifically what capabilities it can address. And again, as we saw previously, they largely fall in under the function of identify. But you can see that it services a wide range of different identify sub-functions across these various asset classes. So hopefully, folks can see how the cyber defense matrix can be useful for gaining an understanding of the various aspects of cloud security. Now, keep in mind, this doesn't mean that you have to implement everything that is here. But it's extraordinarily useful to know that there is something that can be implemented in each of these boxes. Ultimately, it's up to your budget and your risk profile to be able to say, you know what, this is the posture that I would like to have. And based on the assets that you have and the assets that you care about, this becomes a useful checklist that you can use to ensure that your security posture is up to the degree that you want it to be. So with that, let me now turn it over to Aaron, who's going to take it from here.
Thanks, Avi and Sunil. I'd really like this portion of the presentation to be more discussion-based. So please interrupt, ask questions, and challenge any of my statements. This goes as much for my co-presenters as it does for you, those who are on the line and listening to us. So please, light up those questions. Okay, so as a business, Sisense is a hybrid cloud infrastructure with multiple AWS accounts with thousands of assets. This makes up a pretty sprawling AWS estate, which can result in alert fatigue. As with many security teams out there, almost any security team really, the challenge around finding signal through the noise is constant and really not an easy one to solve. And especially for us at Sisense, we are a very lean security team, albeit a mighty one. Managing the sprawl means choosing, the right tools for the job and leveraging automation and just making, intelligent decisions around how we are orchestrating our security infrastructure. So for our solutions wish list that we had at Sisense, I wanted something that could easily, in an automated fashion, take the sum of all our parts across all of our accounts and get a comprehensive view while not impacting our production assets, which we've seen with, as Avi mentioned, which we've seen with agents in the past. We're constantly getting messages from our cloud ops engineers saying that, some agent is gobbling up all of the memory available on a machine. In addition to that, we wanted a tool with open APIs that allowed me to extend the product, which, had the added benefit of allowing me to be heads down in code, which, somebody who was, in the past building out the production product was something that I was really looking for. But by also extending the tool, we could reduce the number of those tools that we needed to manage, which means that we would be able to rely more on native tooling and a small set of third-party tools that we would integrate into our environment. Integrating tools into your environment is something that you always want to be selective about and, solve for your problems opposed to just looking for solutions. So how do we defend the sprawl? So I've come up with 3 high-level ways of thinking about it. The first being aggregation, intelligent tooling, and then relevant automation. So when you are a lean security team, the last thing you want to be is heads down in the weeds day after day. So focusing on these 3 things really helps move your team along. So let's pretend that we get a console login from an unknown location. So I'm sure many of you out there have guard duty enabled. If you don't, I do recommend it. It's a great native tool. You've likely seen this alert a lot in the past few months. I mean, why? Well, this alert is often triggered by an employee who's logging in from an unknown location, so an unknown IP address that activity is usually not seen from that principal, right? And so, with the current state of the world, those who do not have to physically go into their place for employment are working from home, right? So that means we're getting, hundreds of alerts day after day just with this one IAM console login alert. So instead of tracking down each team member that is triggering this alert and asking, hey, is this you? What's your IP address? Instead, we should focus on gathering the surrounding domain events. So fortunately, guard duty and other native tools allow us, pretty deep insight into the metadata that surrounds this event. So we can get, things like the remote IP address, the role, the user, the principal ID, and we can use all of that to then enrich our understanding of the action that the user is taking, and then also enrich what that alert actually means and contextualize it. That way we can then respond and make sense of it. And I call this aggregation mostly because what you'll want to do is centralize your alerting and make it work for you and make something that makes sense in your business process. And we can go into that a bit later when I talk about automation a bit more. And so when I say intelligent tooling, it's not that I'm thinking things in terms of AI and ML. It's that we as people, that's why I have the little guy with the sprocket and the ridge. We should think about tooling that helps do our job better and easier and makes us more efficient, and also allows us to get out of some of the doldrums and monotony of looking through all these events and logs. So as we saw, we get a lot of great metadata about events from native tools like guard duty. And going off the same example, what if I wanted to get an idea of what actions this suspicious login was taking? So if I see this user conducting actions that are typically outside of the actions that they typically perform, I'll be able to find that out through AWS CloudTrail, right? In addition to that, I'll be able to get alerts from tools like Orca if they have opened up a critical port for public ingress, or if they've changed or modified, my VPC in any kind of way. And in addition to that, I'm also able to get a look at the packages that have been installed. So I can get a list of all the packages that have been installed on, any of my EC2 machines. That way I can have a list of permitted packages, that I can assign to my tagged critical assets that I expect to be there. if anything falls with outside of that group, then it's something that I can alert on. And it's something that, we should be aware of in our day-to-day. And with relevant automation in mind, so Neil said it best when, Orca does a great job of helping alert, but it's still on us to perform the protect function, right? So automation is great, and it's something that I'm always promoting on my teams. And it's something that we need to decide on our teams and on your teams what should be automated, what should be developed, and how it should be implemented. So this is a great time to partner with your engineering teams and organizations and your platform teams and help define that scope. But outside of that, some things that we can do on the protect side is, scheduled or on-demand credential rotation. This is pretty straightforward and is something that, we should all be doing anyways. But having something that, if I see a suspicious login and then I see suspicious events occur in CloudTrail, then I can on-demand rotate that credential either in an automated way or by the click of a button. In addition to that, to help respond in the future, I'll be able to block that IP address, especially if I'm hooked into my WAF API. And then in the AWS environment itself, I can close ingress to that port if it was never supposed to be open in the first place. So these are some decent examples of automation that for protect, responding, and then also compliance. So things like EC2 and security group quarterly audits, which I'm sure we've all been through before, are things that are challenging and probably impossible to do from a manual standpoint. And building that tooling using native tools, or even using tools like Orca to pull down all of the assets, everything that we have within all of our accounts, it just makes it a lot easier if you have tooled intelligently. And so I want to just hit some quick best practices that we should all be thinking about when we are operating in the cloud. So, AWS says it best when they say shared responsibility. I say don't ignore it. It's something that both Sunil and Avi have said, which is, it's wishful thinking to think that you're going to shift the onus of responsibility onto your cloud provider, no matter who they are, just because they're the ones that are controlling the asset. It's still on us to make sure that we are using our best practice and we are securing our networks and our assets in a responsible way. In addition, hygiene is a priority. So don't leave dead EC2 instances, VPCs, or stagnant security group ingress and egress rules. Practicing good hygiene will shrink your attack surface, while also giving the added benefit of, cost saving. So now not only are you a security conscious security organization, but also one that's business conscious as well. In addition to that, as you are partnering with your engineering organization, tagging your instances can save you a lot of future headaches. So especially when you're trying to automate priority, right? So when you are building out your cloud infrastructure, it's important to, the crown jewels that Avi talked about, tag them in such a way where you can then link automation back to them. That way you can get an understanding and set a trend line for all of the alerts and events that you are aggregating. And a great way to aggregate that is to use S3 to help pipe in any of those events. And then you can use different tools, BI and analytics tools, to set trend lines. And so that's where hygiene and tagging effectively really makes a lot of sense. And when you are choosing a tool to pull into your AWS environment, outside of the native tooling that they already provide, don't select a tool just because your network is using it for cloud security. Do your due diligence. So look at the team and the technology. Are they passionate about their product and customers, or are you just another entry in a spreadsheet? And ask questions to the product rep around how they respond to customer inquiries. So as a past product engineer, I like to think of things in terms of modules and services. So Do they have an API first approach? Is their tooling extensible? And can I modify it to fit my needs? And will it fit into my program? I don't want an opinionated, heavy, bloated tool that is going to force me to shift my process opposed to allowing my me to fit the tool into my own process. So essentially that can be boiled down to, do they have an API? Is it well documented? Do they have a sandbox or trial account that you can play around with? Or are they even willing to entertain the idea of that? And how do they handle customer requests? And can I extend it to make it fit into my program? How lightweight is it? And how can I plug those pieces together? Being able to extend the tool to fit your program, I think is some of the most important things that you should be looking for when you're thinking about pulling a third-party tool into your environment. And if you have more questions about how we pulled Orca into our environment, number one, you can always email me or hit me up on Twitter, but also you can take a look at this case study at Orca Security SciSense and get a better understanding of how we implemented it and how we are making it work for our environment. So with that, I can pass it to Hillary where we can move into Q&A. Looking forward to seeing those questions and responding. Thank you.
All right, awesome. So we do have a handful of questions that have already come in. For anyone who does have questions, please enter them in the Ask a Question tab that's at the bottom of your screen. I will get started with the first question that I see here, and I believe this one is for Avi, and it says, what do you use for malware detection? Is it only signature-based?
So thanks for this question. I think that it's emphasized one of the unique things that we're doing. By running on a distinct host, in fact, we are not taking the CPU out of the workload, but on our scanners, we're able to leverage a large set of heuristics, and both static and dynamic, for malware detection. So the way that it works is it runs file after file and scans them, including heuristics, allowing us to detect polymorphic malware. And we also utilize another very cool capability that we are able to do due to context, which is to detect if you have workloads that are supposed to be literally the same. Think of an auto-scaling group or another cluster mechanism which have few members. If we see that only one of these members have changes, then this is a huge red flag. And this is something that the context coming from the cloud environment allows us to detect. So in short, a combination of both static and dynamic capabilities combined with context-based heuristic detection.
All right. And we do have one other question that is about the Orca product and asking, does Orca also provide any unique visibility that you could not get with other tools?
Thanks. So there's two parts to that question. First, there's unique visibility in areas that Orca is the only player, almost the only players that perform like detection of lateral movement risk due to the fact that we're able to see and treat the cloud holistically. We can detect that, for example, a specific workload have access to a second one, or things that are more context-based. For example, detecting vulnerabilities that are actually breachable. But the most unique part is the fact that that we are enabling all of the capabilities for all of the environment. So theoretically, you could have installed 4 or 5 different agents on each and every machine to have vulnerability detection, malware detection, secret detection, and so forth. But this is not practical. No one can do that. So I think the most interesting, unique visibility part is the fact that you are able to get all of the tooling capabilities for everything.
All right. The next question I have here is for Aaron, and they're asking, are you automating the use of Orca using APIs or only using the graphical user interface?
So I think just like anybody who starts using a tool, we start out with using the UI, the web application. And then from there, I've been building out our capabilities of use to identify using the Orca APIs. So for instance, taking a look at installed packages, right? I am automating that and getting an insight into what is on every machine and acting on anything that we find out of the ordinary. In addition, we can take a look at SSH logins. I can get alerts on open ports. We can get a look at the ingress that has been open to critical assets that should be within a VPC. I am automating the credential management from a compliance perspective. There's a lot that I'm currently doing there to help make my job easier, and that is why I did choose this tool, was because I can extend the product. I can create rules that will alert me. It's just nice to have a team that listens to your needs as a customer. As soon as we were onboarded, we pulled them directly into our Slack workspace, which allowed me to have a constant conversation with them and a pretty generous feedback loop where we can have discussions around what needs to be added to the product, what makes sense, and they're currently in development, if I can say this, with a newer API, so basically a V2 that will make this even easier for those customers that come in the future. I love automation. I think it's, if I could automate every part of my life, I would try. I would fail, but I would try. And Orca allows me to automate at least a lot of my more onerous and monotonous details outside of my everyday. That way I can focus on being a bit more strategic opposed to tactical.
Awesome. The next question that I have here is for Sunil, and the asker is wondering how or where can they learn more about the framework that you talked about earlier?
Sure. So the easiest is just to search for Cyber Defense Matrix on Google, and one of the first hits will be the OWASP site that I stood up that captures a lot of details about the Cyber Defense Matrix, and about there's a couple slides that capture about 30 or 40 different use cases beyond the one that I just showed here today. So the easiest way is to search for it, but you can also hit cyberdefensematrix.com, and it will redirect you to the OWASP site as well.
Awesome. The next question here is for Aaron, and the question is, how long did it take you to onboard with Orca?
Minutes, honestly. Just to get them into our environment, minutes. Then it takes, depending on the size of your your asset pool. It'll take half hour or so for them to scan all of your assets. But you don't need to worry about that. Just getting them into our actual environment, honestly, minutes. It just makes a call out to a Lambda function that we were able to take a look at beforehand, which is always nice to get an understanding of what's going to happen in your environment. So the way that I did it was I actually spun it up in a protected region where we did not have any assets, and just and set the permissions to only act within that region. And then I spun up a few fake EC2 instances and some VPCs, just so I could see what I was going to get from this tool, and also what it would be looking at. So it's honestly really fast. I spent more time just for my own due diligence, but if you just put it in your environment, it's honestly just a few minutes.
All right, wonderful. The next question I have here is for Avi, and this person is curious about whether Orca can see inside containers.
So thanks for the question. Yes, Orca can see inside containers in all of the supported container ways that you can run within AWS, whether you run your own native Kubernetes cluster, whether it's via ECS or even AWS Fargate. We are integrating to the storage, to the runtime storage layer, and reconstruct the layer file system, and able to probe and scan container in their current run state.
Yeah, I'd like to build on that just to say that, previously we were using, some tools that did our vulnerability management for us, for our open source vulnerabilities, for our container scanning and all of this. But now we've been able to centralize that into one place, where I'm then able to pull down all of the findings. I'm then able to, then push it to an S3 bucket. That way we have some trend analysis there, and then ingest it into our own tool. So I'm able to dog food all of the findings that I get from Orca into a tool in a Sisense Cloud Data Teams dashboard. That way I can get better understanding of, where a lot of these vulnerabilities lie, when and where they are being introduced, when they are being resolved. That way we can, it makes the vulnerability management process a lot easier when you're able to compile everything into one place.
All right. The next question I have here is for Sunil, and the person is wondering, where does technology like SASSY or CASB fit into the cyber defense matrix that you talked about?
Sure, great question. So SASSY, Secure Access Service Edge, for those who don't know, or CASB, Cloud Access Security Broker. So SASSY is based on what service edge you're trying to provide secure access to. So I'm literally using the words to describe where it's going to map. So the service edge depends on the service edge. If the service edge is a web application, then it would map under application, and the function is to protect that application. So if you're putting in a solution, let's say a zero trust access proxy that fronts an application, again, application protect, if that secure access service edge is to actually protect a network, then that would be network protect. If that secure access service edge is to actually service a desktop, a virtual desktop environment, then that would be device protect, and so on and so forth. YL Ventures actually has a company that is covering the same kind of concept except for data. So it's a data broker or a data access broker essentially that allows us to provide a secure access service edge for data, and so that would be under data protect. For CASB, that would be under applications. To SaaS, CASB's address software as a service, and so that would be under the category of applications. And the goal for CASB's has been to really extend our security controls to be able to do identify, protect, detect, respond, and recover. But in reality, CASB's really have, frankly, not really delivered on the promise that we had hoped for. It tries to do the basic function of identify in terms of inventorying the SaaS applications that we use, and then subsequently trying to protect our usage. But what we see mostly is a fairly limited number of SaaS applications that can be inventoried, and then mostly the protect function is around a DLP function. So whatever information we've put into a SaaS application, we want to try to secure. We're starting to see the emergence of new capabilities in the cloud detection and response space, so application detect and application respond, but that's still a fairly nascent market. So that's where SASSY and CASB fit within the cyber defense matrix.
Awesome. Thank you for that. The next question that I have is for Avi. And so this person is kind of wondering, you talked about this side scanning architecture, and, this seems to be kind of unique to Orca. Is it better to just install agents and get over it? Why aren't other companies using this approach?
So, interesting question. I gave it a lot of thought myself, naturally, and I think it's a combination of reasons. First, many of the large vendors have been doing security via agent for many years, either agents or via network scanners. And when you're doing something for so long, it's just very easy for you to continue and use the exact same tools that you've been using and shift them and adapt them a bit, but not starting from scratch. And what we do in Orca side scanning is essentially starting from scratch. We need to probe a workload without communicating, without running on it from the side, building it only from the view. And this requires starting from scratch, and this is something that large companies don't really like. They like to use what they have and to leverage their IP in different ways. And a second issue is that it simply wasn't really possible until approximately 2 years ago. This approach via leveraging the runtime block storage and reading it from the side wasn't possible without performance it until approximately 2 years ago. So it's essentially there was a very short window of opportunity. It's not like someone could implement it 5 years ago. So I think it's a combination of these reasons.
All right. The next question I have here is for Sunil, and it says, how can I get started using the Cyber Defense Matrix?
Sure. So for one, I'm more than happy to help folks get started on that. So you'll find my contact details on the OWASP website. If you go to the OWASP website and look at the project leads, it's pretty easy to find my email address there. Feel free to reach out to me, and I'm happy to get you up to speed. But as I mentioned, there's tons of other content out there, briefings and videos and whatnot. So I would encourage you to take a look at one or two of those, and then if you have any questions, definitely feel free to reach out. There's, as I mentioned, roughly 40 some use cases that cover everything from rationalizing technologies to balancing your portfolio to my original use case, which was just mapping technologies, as you saw today. And a whole bunch of other ones that people have that I've come up with in collaboration with others as well.
Wonderful. Well, it does look like that is all the questions that we have. If anyone does have additional questions that they come up with, either while watching the recorded event or after this webinar has concluded, feel free to reach out to the Cloud Security Alliance research team at research@cloudsecurityalliance.org, and we can get you connected with the presenters today. Big thank you, Aaron, Sunil, and Avi for presenting today. I know it takes a lot of time to put together these webinars. You guys provided some great insight today. I'd also like to say a big thank you to Orca Security for sponsoring today's webinar. As I mentioned at the top of the webinar, Orca Security, will be reaching out to everyone on the call that has opted in to contact and will be providing you with the slides. I saw that there was a question in there about that. Down below the presentation screen, you'll find a tab to rate and review the webinar. Please do so we know what content you're enjoying and what we can improve upon. And finally, the recording of this webinar will be available within minutes of the conclusion. You just need to use the same link to rewatch. To view other recorded webinars from CSA or to sign up for new ones, you can go to cloudsecurityalliance.org/research/cloudbytes. Thank you everyone so much for attending today's webinar. Have a wonderful day.